let's look at how we get from our hypotheses to a probability. So choosing your hypotheses is a lot like calling a coin flip. You have to call heads or tails before the coin is revealed. Similarly, you have to choose your null and alternative hypothesis before you look at your sample data. Ideally, you would want to choose your hypotheses before you even collect that sample data to avoid the temptation of bias. In a hypothesis test, we start from the position of assuming that the null hypothesis is true, and then we gather evidence or data to see if the null hypothesis is believable, or if we think that the evidence is strong enough that the null hypothesis is not likely to be true. So this process is a lot like a jury trial. And in a jury trial, the null hypothesis is that someone is innocent. So the jury listens to the testimony and looks at the evidence from the initial standpoint that the defendant is innocent. Then they have to determine whether the evidence makes sense if the defendant is truly innocent. So that's where we get that saying that they're innocent until proven guilty. And the decision they reach, they have to do so with a standard that is beyond a reasonable doubt. So let's take a look at what that means. So since a hypothesis test is designed to assess the strength of the evidence against the null hypothesis, the fundamental step in this process and in our reasoning is the question, are the data surprising given the null hypothesis? So let's think of an example. So suppose my friend Laurel, who's the registrar at Western, is accused of stealing the Mad Jack statue out from in front of Taylor Hall. If the evidence we have is that her car or her truck was parked in the Taylor Hall parking lot, well, there's a lot of reasons that her car could have been there. She works in Taylor Hall, and so that's not very strong evidence that's going to convince me to switch my mind from Laurel is innocent to Laurel is guilty of stealing Mad Jack. Now, suppose that some more evidence is presented and there are receipts for tools and equipment that would be needed to take a statue off a pedestal and put it into a truck. Okay, well, now the evidence is starting to look a little bit more suspicious for my friend Laurel. And then the final bit of evidence that really seals the deal is there are pictures on social media of Mad Jack in Laurel's backyard. Right now I have evidence that the null hypothesis is not true. Laurel is not innocent, but she is in fact guilty. Now, Laurel didn't steal anything. She's a very lovely person, but hopefully that gives you an idea of what we're talking about as that evidence gets stronger and stronger. So specifically what we're going to do is we want to find the probability of getting the sample data we got or something even further out there or more unlikely given that the null hypothesis is true. So the way that we're going to do that, to find that probability, we're going to calculate a standardized score, which is a lot like a z-score, and that thing is called a test statistic. So that formula is going to be z is equal to x bar minus mu divided by sigma over the square root of n. So if you look at that bottom part of the fraction, you see that sigma over the square root of n, and that's our standard deviation from our sampling distribution again. And then the top part of that fraction looks exactly like it does when you calculate a z-score. So once you have that z-score, we can use like the Rossman chance app to find the probability remaining in the tail of the distribution. So you're looking for that probability that's out in the tail beyond the test statistic. All right, so an example, in chapter 15, we looked at the frozen soda drinks and whether whether the restaurant was shorting their customers. They claimed to fill the cups to 20 ounces. So my null hypothesis here is that mu is equal to 20, which is a full fill. And the alternative hypothesis is that mu is less than 20. So we were shorted some of that drink. So if the mean for 50 drinks is x bar equal to 19 with sigma equal to 0.5, I can plug these values into that test statistic formula. So I get 19 minus 20 over 0.5 divided by the square root of 50. And that gives me negative 14.142. So based on what we know about z-scores, negative 14 is absolutely an outlier. And so using the Rossman chance app, we find that the probability associated with that z-score of negative 14 is 0. So in other words, we do have evidence that they are shorting those drinks.